Okay, so we're going over these questions, the one we missed most often. The first one says, find the derivative d over dx, inverse sine of 8x. In order for me to take the derivative here, the key is understanding the derivative of arc sine. The derivative of arc sine is 1 over, what's on bottom? Square root, 1, and then what's my sine? How is tangent different? Plus sign and no square root. Cosine would be a negative on the top. 1 minus the baby squared times the derivative of the baby. So when we set this thing up, we're plugging in the baby, the inside part, the 8x. And then out here, what am I going to multiply by? 8. So this is the same thing as 1 over the square root of 1 minus 8x squared is the same thing as... And then on top, I've got an 8. So 8, it's not negative. It is A. Is that correct? Yep, it's that one. It's A. Make sense on the first one? What other ones? Number 10. So this is the one we kind of talked about a little bit earlier. Use implicit to find y prime. So when I'm setting this thing up, I'm taking the derivative of 4x cosine y. How many variables are in that chunk right there? There's 2. There's an x and a y. So if there's 2 variables, how am I going to have to take the derivative? Product. So we are doing first 4x times the derivative of the second. This is where you probably made your mistake. Cosine y. Remember our circle of trig. Sine, cosine, negative, sine, negative, cosine. We're going this way. So if I've got cosine, what's my derivative going to be? Negative sine. Rewrite the baby. The baby is y here. And then I have to multiply by the derivative of y, which is dy dx. First times the derivative of the second, plus the second, which is cosine y, times the derivative of the first, which is 4. And that whole thing's going to be equal to 0. Anything that has a dy dx is going to stay on the left side. Everything else is going to the right side. So I'm going to subtract that 4 cosine y to the other side. I'm going to divide this dy dx out of it. So I'm going to divide by negative 4x sine y on both sides. And I look to my final answers, and none of those are there. But I still could cancel this negative 4 and that negative 4. So I get cosine y over x sine y. That's the right answer on that one. Number 12. We talked about this one a lot. Most of our issues with this one is we just don't like the notation. Okay, so if I'm setting this guy up, what's the thing that stands out to you here? What's the tip-off for as to what we need to do? The inverse. We are doing the inverse of this problem. So when we set up an inverse problem, I need to know the original ordered pair. I need to know the inverse. The inverse of f is this guy right here. This is the inverse. This is the original. It's f. If I'm trying to find d over dx, that means the derivative. Okay? D over dx at what value do I want it at? 1. So you're finding the derivative of the inverse at 1. That's the ultimate goal. So I know my x value is 1. So that means this y value is 1. I need to find f prime at whatever this guy is. That will tell me what the derivative at 1 is. And so how do I find the x value of the f function? Set it equal to, because it's the y value. And so I'm taking this x cubed over 27 and setting it equal to 1. So I'm going to multiply both sides by 27. And then I'm going to cube root on both sides. So my x is going to be 3. So then I want to find the derivative at 3. And so I need to take the derivative of this thing right here. That's f. I want to find f prime. So to take the derivative, I'm going to think of that as like 1 over 27x cubed. So I'm going to multiply by 3 and decrease my exponent. 3 divided by 27 is 1/9. And I'm going to find that derivative at 3. So I'm going to plug 3 in right here. So that's 9 times a ninth, which gets me 1. If I'm doing the inverse, what do I need to do with that 1? Flip it. It's still 1. The answer was A. A lot of steps on that one. Those problems take a little bit of time, but they're not crazy tough. You just have to make sure you're methodically going through and hitting it in the right order. Any other questions in particular as you were looking over that? That was one class. Let's look at the other class, see how we did. If there was one in particular we struggled with that one didn't. Number 11. Yep, let's look at this one. Cosine x minus 3 over x cubed. The reason we missed that one is this part right here. Don't let that second part throw us off here. I hate fractions. If I can rewrite this thing as not being a fraction, that's what I'm going to do. Do you have 2 variables in that thing? If there's not 2 variables, then you don't need quotient rule. So instead, I'm going to set this up as minus 3x to what power would be the same thing as putting x cubed in the denominator? Negative 3. So this is what I'm taking the derivative of, cosine x minus 3x cubed. The derivative of cosine is negative sine. The derivative of negative 3 to the negative 3x to the negative third, I'm going to multiply to get positive 9. X to the negative 4. I'm finding this derivative at pi, so I'm going to plug in pi. Sine at pi. So here's my unit circle. Here's pi right there. The ordered pair is negative 1, 0. What is sine going to be at that ordered pair right there? 0. It's the y value. It's nothing, so this means nothing to me. 9 pi to the negative 4th, that's like 9 over pi to the 4th power. And if I look at my answers, it's 9 over pi to the 4th power. It's B. Other ones? Anything else that stood out to you that you want me to go back and look at? Yep, no. Which one? This chart or the other chart? The other chart. Yep. We're finding the inverse at the value. So we are finding... No, the other class did too, so you're fine. We are finding the inverse function. Since it says inverse, my original point is going to be with f, and my inverse is the other one. That's h. In this case, I know nothing about h, but my ultimate job is to find h prime at 3. So I'm finding the x value to be 3. So that means the y value of my f function is 3. So I'm looking at f, and not f prime, but regular f, and I'm going to find when the y value is 3. So that's right here on my chart. The f is 3 at 2. So I've got that. Once I've done that, what do I need to do? F prime, yep. F prime of 2. And so then I'm looking at my chart, f prime at 2. That's this guy right here. That's 4. And so my inverse derivative is going to be the reciprocal of that. It's 1/4. Anything else? Any other problems that you want me to talk about that threw you off? Yes, sir. The other table problem? Yes, sir. I think that was down here. Someone's going to get a seizure as they watch this video. It's fun. We're finding the derivative. H of x is equal to f of g of x, and we're trying to find h prime. So obviously we need to find the derivative. If I'm finding the derivative of that thing right there, we see a lot of parentheses. So what do you think we're going to do to take the derivative? Chain rule. So h prime is going to be equal to the derivative of the mama. We're going to rewrite the baby times the derivative of the baby. So the derivative of the baby is going to be g prime. And we're doing that at 3. So I'm going to plug 3 in. F prime g at 3. So g at 3 is 2. Times g prime at 3. G prime at 3 is 1. And then I'm doing f prime at 2. F prime at 2 is also 1. So 1 times 1, my answer is 1. Any others? Yep. The cube-related rates problem. Zoom out. Cube-related rates. A cube shrinks so that the length of its sides are decreasing. And so what you have to think about on this one is it's a cube. And so if I've got a cube here, the idea of a cube is that all the sides are the same. And so the volume of a cube is length times width times height. But since all of them are the same, it's side cubed. Decreasing at a rate, so ds dt is 4 and s is 5. I'm going to take the derivative of that. 3s squared times the change in s over time. So it's going to be 3 times 5 squared. ds dt is 4, but it was decreasing at 4. So what else do I need to include there? It's a negative sign. So it's 3 times 5 squared times negative 4. So 75 times negative 4 is going to be my final answer. I'm guessing that's negative 300.